Hello everyone, and welcome to Making the Best of It, a daily video series helping you make the best of your time at home. So I had a friend write into me the other day asking about Lego projects. And one of the things that unfortunately I didn't manage to bring with me from my classroom to my house is the giant collection of Legos that we have there. But I do still have a great challenge for you all today that involves Legos. But don't worry if you don't have any Legos. I have a second part of this video where I'm going to talk to you a little about 3D printing and show you how I'm going to fix an issue that I've been having with my 3D printer, including just a kind of a demonstration of how soldering works, which is melting metal to connect two wires together so that they can carry electricity between them. So stay tuned for that even after the challenge. So today's challenge is called Crash Test. So the basic idea with this is to take a set of Legos and build a car. Now if you don't have something where you can actually put wheels on, that's okay too. You can kind of just fudge it a little bit. But the goal is to be able to knock this car off the highest thing that you can find without having it fall apart or break. So as you're doing this, you want to think about design, like how do you make it so that when something crashes, it doesn't break to pieces. And what I would recommend is to start with something small, like maybe a coffee table, and knock it off of that. And if it seems to be doing well, then keep knocking it off of higher and higher things. And it's also totally normal and actually really great if it does break, because that means that there's a place where you can improve your design. It's really important to get a good base and experiment with a couple of different things. Maybe you find something that works really well right away, or maybe you need to take a little bit of time to kind of play with some different ideas. So have fun trying that challenge, and stay with me if you want to hear a little bit more about 3D printing. So welcome back to my basement. Today we're going to talk a little bit about how 3D printers work, and then I'm going to show you how I'm going to fix a problem that I'm having with this printer. So first of all, I always tell people the best way to think about a 3D printer is as a really fancy glue gun, okay? So hopefully you all have some idea of how a glue gun works, but the basics are that you have the hot glue, or well, it's the not hot yet glue. You have the glue that goes in the back, and then this part right here, if it were plugged in, this would be hot. And then to make the glue go through here and melt and be able to come out, I would squeeze this trigger. It's not plugged in, but that's what would happen. Now, if I were to take this glue gun and have it all heated up, and on this tabletop right here, draw a square out of glue, and I stopped, I made sure I let it dry, let it harden completely so it's not hot anymore, and I ran my hand over it, I would feel a bump in the shape of a square. And hopefully that makes sense. Now, what would happen if I were to take the glue gun and draw a second square right on top of the first? Well, I'd have a little bump that was a little taller and still in the shape of a square. And if I kept doing that and doing that and doing that, then eventually I would have a tower. And it would just be glue built up layer by layer by layer. And that's exactly what a 3D printer does, but it does it a lot more accurately, and I don't have to sit here guiding it on my own. There is a computer that does it for it. Okay, so let's talk about how the parts of our glue gun line up with the parts of our 3D printer. So right here, this is our 3D print filament. It is a hard plastic. I use PLA, which is polylactic acid. That's like the chemical name for this plastic. This is actually a really cool plastic. It's technically biodegradable, and they use it in stitches that are really deep inside of your body where they don't want to have to go in and take them back out, because PLA is biodegradable, and so your body can kind of melt it down and get rid of it on its own. Super cool material, obviously not exactly what they would put in stitches deep inside of you, but it's cool to know that that's another thing they use this material for. But this filament is what we call this PLA filament, is the equivalent of the glue in our hot glue gun. And then this right here, this is the part that gets hot. So in here is like our heating element, and so that we can think about that as the nozzle. It's really small, you're not going to be able to see in the video, but right underneath here there's a little tiny nozzle that actually looks like a very mini version of this. And that is where the melted filament is going to come out. We have a trigger here to pull with my finger to make the glue come out. This right here is a motor, and it turns and pushes the filament out so that it can come out of the tip, just like our finger is doing by pressing on this button. Okay, so we've got the basics of the glue gun, but now there is, how does it move around, right? Because in my glue gun example, I've got my hand and I'm kind of guiding it. In this case, we have some motors. So there's a motor right here, and that, on a belt, makes this go back and forth. There's another motor back here, and this goes back and forth similarly. And there's two motors right here that can raise and lower this. And having those three different directions, X, Y, and Z, lets us move anywhere we want on this build plate, which is what we call this. Then we also have a computer. It's kind of back here. It's a little baby one. It's not like you can't run games or anything on it. It's just for working with the 3D printer. And then we have our screen right here, and then there's a little memory card right here where I put the code that tells the computer how it wants the 3D printer to move to make an object. And I generate the code that goes onto this memory card on my normal computer. So that's the basics of how this works. Now the issue that I'm having right now is that this right here, my bed, isn't heating up properly. And when it's not heating up properly, it gives a little error and it stops whatever it's doing, so it's stopping in the middle of prints. It turns out, though, that it's actually not that the bed's not heating up, because it is getting warmer, but there's a sensor on the back, something that senses, just like our eyes sense light, and our fingers can sense like textures and patterns. There is a sensor on this that is made to sense the temperature of this bed and then send it back to the computer. But that sensor has a broken wire. So what we're going to do today is, rather than replacing that sensor, which I could do, I'm just going to try to fix the wire. Now I've done that once before, but it didn't quite stay fixed the way that I wanted it to, so I'm going to try one more time. And the reason I'm not just replacing it is because I think it's really important to try to fix things where we can and to waste less stuff. So what I'm going to do right now is I'm going to heat up this so I can pull this filament out. And I'm also going to heat up this, which is my soldering iron, which are the two things that I'm going to need to do before we get started. So I'll get back to you when those two things are done and show you what we're going to do next. Once I've unloaded the filament from the 3D printer, the next step is to take off both of those rolls of filament that are sitting on top and then remove the holder for the filament as well. After that, I'll start powering it down by pressing the button on the side to turn it off and then unplugging it as well, just to be sure that absolutely everything is off. Then I reposition the 3D printer so that I can access everything that I need to. The wires that I want access to are connected to the heat bed by a couple of screws, so I'll undo those screws. The wires also have a protective wrapping around them, so I'll take that off so I can see the actual wires that I'm trying to get to. Once that's off, it's pretty easy to see the place where I patched in two new wires, and as soon as I touch it, the wire that's causing problems comes right apart. And you can compare that to the yellow wire just next to it that I also patched in, and that one is nice and secure. I'm going to take the electrical tape that I have wrapped around both of those points off so that I can see what's going on a little bit better and make sure that the joint on the yellow wire actually is still good. Once I can see that that electrical joint is good, I retape it with electrical tape. It's really important to cover any joints like this with something that doesn't conduct electricity, because if two of your joints were to accidentally touch each other and they weren't covered up, it could cause a real problem. Now at this point, I just decided to replace that blue wire entirely. It had been giving me problems for a while, and I thought that there might be a couple reasons for that, and so I decided to just take it out. So the first thing that I thought might be happening is maybe that blue wire was just a little bit too short, and so it was pulling more on that electrical joint than it should. Something that's important to know is, while we are using metal to join two pieces of metal together when we're making solder joints, those joints actually aren't meant to hold any weight. And so having that piece of wire be too short could have been making that joint hold weight and causing it to break more frequently. The other thing I thought was that maybe I needed to use a multi-core wire instead of a single core wire. Basically, a single core wire is just one thick piece of wire, where a multi-core wire has lots of little thin pieces of wire all together inside and kind of making up one wire. Multi-core wire is a little bit more flexible, and I was thinking, well, maybe if this is rubbing against something or bending too much, having a multi-core wire instead of a single core wire could help. Now that I have the joints exposed, I'm going to use this soldering iron, which is a really hot thing that you should definitely not be touching without adult supervision. And what it will do is it'll melt the little piece of metal that was on there connecting them, so that I can take that piece of wire off and be able to attach another piece of wire. For the piece of wire that I'm attaching instead of the one that I just took off, I'm actually using a piece of wire that's attached to an old motor, because I didn't have any other multi-core wire on hand. Once I've cut off the piece of wire that I want to use, I use this tool called a wire stripper to take the plastic protective coating off of the ends so that I can connect those ends to the ends of the wire that's on the 3D printer. Once I've stripped the ends of the wire that I'm adding, I also need to strip the ends of the wire that is currently attached to the 3D printer. Now, there are a lot of ways to make sure that the two things you want to solder together are touching one another before you actually solder them. In this case, I'm just taking the two pieces of wire and twisting them together so that they stay attached without having to get any other tools involved. Now it's time to solder. Remember, this is not something you should ever try on your own without adult supervision, for a lot of different reasons. The first thing that I do is clean off my soldering iron and then test that it is hot enough by touching it to the solder, which is that metal in my left hand that has a low melting temperature and is what we use to join two wires together. Once everything looks good, I touch the soldering iron to the two wires, and then I put the solder against it as well, and the solder melts, joining the two wires together. Once that joint looks good, I will put my soldering iron away for a minute, twist together the other side, and do it one more time. Once both solders have cooled down, it's time to take some more electrical tape and wrap them up. Once the wires are all safely bundled up, I can put back on the little faceplate that I took off earlier. Once I'm all done there, I can flip the 3D printer back to its normal orientation, and then I'm going to use a popsicle stick that I split in half to try to make a bit of a stabilizer around these wires, because again, one thing that I'm thinking might be happening is that there might be too much bending going on in the wires, causing them to break, particularly because the bending is happening right where those wire joints are. In this case, I'm using just a little bit of hot glue, putting some on one stick, and then sticking that stick to the bottom of where those wires are going in, and doing the same thing with the other half of the stick on the top. I'm using just a teeny bit of glue so that if I ever want to take it off, it is really easy to do, and also being very careful to not get it into any of the holes where the screws go. Once that's done, I put the wire wrap back around the wires. This definitely would have been easier to do before I put the popsicle sticks on, but sometimes that's the way it goes. Once that's all set, I put some electrical tape around the whole thing just to make it so that the wires can't slip out the side, and after that, the 3D printer is basically ready to go. After that's done, I can turn the 3D printer around and start powering it up. I do that by plugging the power cord back in and flipping the switch on the side. Once the power comes on, I ask the 3D printer to preheat, so to try to heat up both the bed and the nozzle. And while it's doing that, I start putting the 3D print filament back on top of the printer. Once it's hot enough, I press a button on the 3D printer to tell the 3D printer to load the filament, and then it pulls the filament right in. After that, I prepare the print bed for printing by putting some rubbing alcohol on top. Once the printer is ready to go, it starts making some initial movements to bring the print head, so that's the place where the filament is going into, to its home position. And once it's there, it goes through a procedure to make sure that the bed is perfectly flat. It has a sensor that detects magnets on the print head and then some magnets in the print bed, so it goes around and makes sure that all the magnets are right where they're supposed to be before it starts printing. Once it's done with that, it gets started printing layer by layer until it's completely done. This is printing a set of the Manta face masks that I showed you in my video the other day. And if you look closely, you can see the outline of the face masks start to appear. Have a great day, everyone, and I hope to see you all soon. Bye!